Hello, everyone, and welcome to this session offered to you by Logics Academy, Unlocking Robotics Skills with FTC Sim. Your team for today. My name is Martin Peltier. I'll be here serving you as a co-pilot. I'll be with today's host, Dominic Tremblay. He's part of the extended Logics Academy team from Belleville, Ontario, and myself. I'm part as well of the extended team at Logics Academy. I'm located in Moncton, New Brunswick. So it's a real pleasure for me to be with you today. And just before we get started, because I'm on the East Coast, I'd like to do a land acknowledgement representing my area of the country. So I would like to recognize that we live and learn on the traditional land of the Mi'kmaq and Wolastoq people, who are part of the Wabanaki Confederacy, and we are thankful for their care of this land for thousands of years. This is a beautiful place to call home, and as the season change, it's a great time to enjoy being outside. Whether it's biking in the forest or walking on the trails, you can smell and feel the nature's changing, seeing the nice colors. So we're so lucky to be here in Canada. We'd like to thank First Robotics Canada or First Canada here for sponsoring this event today and making this possible. And also, it's important to know that this is a live event. You can see and hear us, but we can't, okay? See or hear you. So what we will ask from you is for you to check in with us and open a new tab or a new browser and put in this website or this code and connect with you. When you put in this link, I'm going to ask you today, put in maybe your first name, maybe the school where you're from, maybe the area or the province, maybe your teacher, just the first name or last name of your teacher, Mr. B or something like that. So we can say a little hi or a shout out to the people today that are here with us. Again, feel free to go there. And if you need at any time, this is also a YouTube live. So if you need at any time, you can press pause and do the activities that will be shared by Dominic. And you can press pause at any time, go back if you've missed some important information. We would like to hear from you. So first, we would like to hear a practice. We want to have a practice question with you to see if the link works, if you can communicate with us. So here we would love to know, what do you know about coding? What's your favorite thing about coding? Maybe you're brand new to coding. What coding means to you? So we really want to know what coding means to you here. So I'm going to give you a few seconds here to connect with us. I'm going to open my link to see your answers. We have Mr. B's class here that has done some coding. We have the New Dundee superheroes. We have Mrs. K here. We have Mr. Mark, Mr. Johnson's class. Thanks for joining us. Some are new to coding, I can see. Some like block coding, some like the coding in Scratch. Cool. All right. So we'll get going with our presentation here. And we'll get back to you for some more questions. So here we are, we're with Dominic, and I'm gonna let Dominic roll here and tell us about FTC SIM.
Hello, everyone, and this is your FTC Sim workshop. This is the student workshop. I'm Dominic Tremblay, and I'm going to be presenting today, showing you all of the things that you need to know to use the FTC Sim platform. And I know Martin is behind the scene, is looking at all of your answers and your question. So make sure that you keep using the form to answer the questions that I have for you. I also want to say that this Logics Academy workshop has been brought to you through the generous support of First Robotics Canada, and I really appreciate this beautiful platform that they've created so that you can do robotics online without the need of a big robot. So teachers, if you're listening, uh, using FTC Sim, which is a simulator, is a great way for you to introduce your students to robotics without the initial cost of purchasing robot. So on the platform, and you're going to see it through the workshop today, your students will be using a virtual robot that works in their Google Chrome or Microsoft Edge browser. So it's a great way for them to get familiar with the platform and see if they like it, see how they like completing the challenges. And the great thing as well is the kind of coding that they're going to be doing today is the exact same interface that they would be using if they get those robots and they start solving problem for the real first robotics challenges. So I think you're going to find this amazing. And let's get started. So students, throughout the workshop, we would like to hear from you. And Martin will be checking this form for me, and we'll be looking at your answers and your questions. So if you have a question or if you have an answer for me, you need to open a second tab in your web browser and go to this address. You can take note of it, bit.ly/logicsform1. bit.ly, that's with a Y, /logicsform1. And we're going to ask you two questions. The first question is, what is your name? Always give only your first name, or even better, your nickname. You never provide your full name online. And then you can either put on the second section, either your answer to my question first, we're going to start with the short icebreaker activity. It's going to be a question using the form. Then we're going to explore the FTC Sim platform, just to make sure that you know how to find your way around the platform. And then we're going to start solving some challenges. We're going to work on the robot movement. So we're going to make our robot move today. And near the end, in the last 5 minutes, I'm going to show you how you can go further, because this is an intro workshop. This is to get you excited and make sure that you have the skills that you need to get started with robotics. But obviously, if you want to continue doing robotics in the future, you can continue doing it without me on the platform. So that's why we're going to go further. So let's start with our short icebreaker activity. And in this activity, what I'm going to ask you to do is I'd like to know what kind of experience you have with robots and coding. Maybe you've been coding some Lego robots, maybe Lego Mindstorms EV3, maybe some Lego Spike, maybe you're using the MBot or the Vinci bot, or maybe you're using robots like Sphero. Ozobots would be a great one. I'd like to know which robots you've been using in the past, if you have, or which coding platform you've been using. Maybe you've done some coding in Minecraft, maybe you use Scratch, maybe some of you have done coding in Python, maybe you've created a website using HTML5 or PHP. I would love to hear. So I'm going to disappear and Martin will take over. We'll summarize your answer and then we're going to continue the workshop.
So again, we have a few answers. We have some people that have done Scratch. Oh, we have a Make Code Arcade. I think we have participants that participated with some session with Dash Robots, MBlock. Thanks for all your answers.
Okay, I'm back, and I'm glad to see that some of you have some experience with coding and robotics. And as an example, this is a robot called the MBot. And I've actually flipped it because I want you to see the motors. We're going to get back to this because the way the motors are organized on the robot, the way they are installed, really affects how the robot works. So now some instructions for you teachers. For the lesson to work, you need to make sure that your students have an account on ftcsim.org. So let me share my screen and show you what I mean by that. And if they don't have an account, what I suggest is that you pause the workshop and you take some time to create an account for your students. So how do you know if you have an account? So let me load FTC Sim here. So as you can see, right now, when I load ftcsim.org, so ftcsim.org, this is where you need to go. If you get here and all of these challenges are locked, that means you're not logged in. So your students need a user ID and a password to access that. So students, if you don't already have a user ID or a password, make sure you ask your teacher. Now for the teacher, what you need to do is you're going to need to go under login and you're going to need to sign up as a teacher. And then you're going to fill out this information. And let me show you, once you've opened your teacher account, what it looks like on your side. So give me a second. I'm going to show that to you. Okay, give me a second. Let's do this. I'm going to share my other screen. And you should see that. Give me a second. So this is what a teacher's account looks like. And now I'm really talking to teachers. So in your account, once you have your account, you're going to go in the triple line and you're going to go under My School. And you're going to make sure that you add a class here. So let's say I have a grade 8 class. And this is grade 8B. And you're going to add the class. And then once your class is added, you're going to go under View here. And you're going to add all your students one by one. So add students, you're going to put first name, last name. You don't actually have to put their real last name. You can also create some generic account and then create username and password. Just make sure that the username are unique. So if your student is Bob, well, Bob is probably used in the world, in Canada by someone else. So make sure that you add a couple of letters. So like Bob671 would be a good username. And then password. So teachers, I'm going to give you some times, and what you should do right now is here, if you don't have account for your students, take some time to pause the workshop. This is the magic of watching it on YouTube Live. You can pause. And then once you have all of your account created and your students are good to go, you can come back and we're going to get going. Perfect. So now let's go back to the students. Let's imagine that I'm a student. My teacher has given me my username and password. So let me show you what you're going to be doing. So I'm going to share my screen, my student screen. 1 second. Okay. Here we go. So students, you're going to go under login. And you're going to use the username and the password that were provided to you by your teacher. So let me do this. I'm going to go in my account here and I'm going to log in as a student. So this is, I'm going to be Lucas for today. So let me enter Lucas username and Lucas password. So use what your teacher gave you. Oh, I forgot the L here. Here we go. And now I'm logged in. I know that I'm logged in because see, those activities are now accessible. If you are there, you're good to go and we can start learning. If not, if you need some extra time, now would be a good time to pause the workshop and do that before we continue working. Okay, so now I think we're ready to get going. Hopefully you have your account. So for today, we're going to skip the FTC intro because you have me. So you don't need the FTC intro. In the future, if you want to watch the intro, good for you. But now we're going to move directly to our first series of puzzles called FTC movement. So I want you to click on FTC movement, and you're going to see a bunch of puzzles showing up here. There are 10 of them in this section. Today, we'll probably have time to work on maybe 2 or 3 of them, but then you can continue. That's the magic. Now, once you know how it works, you can continue working on those puzzles. So we're going to start with the easiest puzzle, and you see it shows you the difficulty level. So we're going to start with the easiest. It's called line number 1. So let's click on this one. It may take a bit of time to load, so let it load. It's loading. Perfect, perfect. And by the way, this will work on any computer, Windows, Mac, Chromebooks, and you can, as long as you use Google Chrome or Microsoft Edge. Don't use Firefox or don't use Safari. They won't work very well. We're gonna let the simulator continue loading. Here we go. And depending on the speed of your network at school, it can be slower or it could be faster. Now, you're going to meet Lisa and her dog right here. That's Dozer. That's Lisa's dog. So normally we would listen and watch the story here, but because you have me, again, we can delete this and get started with the puzzle immediately. But when you're completing the puzzle, I encourage you to read the stories. They're always interesting, and they may provide you with some hints to solve the puzzle. So this is our robotics room. So let's take some time to explore it. So same thing on your computer. You can use your mouse. So I'm going to be using my trackpad on my laptop now. And I'm just clicking and moving my finger on the trackpad to look around. See, this is one of the rooms that is perfect for robotics. We have a 3D printer here. We love 3D printing when we do robotic. Sometimes we miss a part. You see we have a water cooler. It's important to be well hydrated. Looks like we have some boxes here. We always get new equipment when we do robotics. And I think I see some donut right here. Donuts, yeah. And a healthy lunch, because we want to have a healthy lunch, but if we need a bit of sugar, a little boost, we have our donuts there. And we've got some posters and a computer to do our coding. Now, you may be wondering how I zoom in and zoom out and I move. So to move, I use my mouse, my trackpad, but you can also use the key called ASDW. So I encourage you to try those keys, ASDW on your keyboard. W will let you zoom in, S will let you zoom out, A will let you slide to the right or left, and D will let you slide to the right. Now, you probably saw that I was going up and down. You can use those letters that are just above ASDW. So Q will make you go down, and E will make you go up. So that's a great way to move around in the world and see the things that you really want to see when you are completing your challenge. Okay, so now we're going to spend a bit of time looking at the robot that has been provided to us. And I'm going to zoom in on the robot. Zoom in. I'm going to move down a little bit. So this is the robot that is provided to us. So as you can see, you have 2 wheels on the back, and the wheels on the backs are the one where the motors are attached. If I zoom in, you're going to see there's a motor attached to the 2 wheels. 1 motor per wheel. This is a bit what I was showing you in the PowerPoint earlier when you saw my MBOT. Now the wheel on the front, they're not actual wheel. They're designed to slide. So let me go up a little bit here and show you. I'm going to zoom in from the top. So those wheels don't have power. They don't have motors. They're just designed to slide to the left and slide to the right. We have the battery and we have the microprocessor here. And that's about it for this robot. So just keep in mind that the front of the robot is where you see those green things. This is the front of the robot. So when we get the robot to move forward, it's going to move in the direction of those green things. So here we have our first challenge, and it's a very simple challenge. The idea is that you need to move your robot from where it is right now all the way to the trigger pad or the victory pad. When you do this, it's going to raise the flag, meaning that you've successfully completed the challenge. Now, in all the challenges, you're going to find also those Thunderbolt. These are bonus points. You don't have to grab them, but if you grab them, you get more points. So it's always fun to grab them. In this case, it's going to be fairly easy to grab it because you're going to be moving, you're going to be collecting it, and then reaching the pad. But in some challenges, it's a bit more work to go and grab those Thunderbolt. Now that we see this, you should see the big run button here. This is to start the code and reset. Now, obviously, we don't have any code yet. And just to finish, to start coding, we're going to click on the big green icon here on the left-hand side, and that's going to open up the code. So make sure that you take some time to move around and explore the arena that is there for you, and then open up the code, and we're going to be ready to get started. So I'm going to give you a few seconds to get organized, and we're going to start looking at writing some code. Okay, so let's do some coding here. So I'm going to zoom in here. So I have the plus to zoom in. So right now you have some sample code that will do nothing. Like if I run, nothing happens, okay? Now, those blue blocks, this is basically instructions to help you know what each part is all about. And in this case, we won't be using a loop block. A loop block is a block that is being repeated over and over again because we don't need it for this challenge. I suggest to make our code simpler that you take this and bring it into the trash. Perfect. So now our code is simpler. We have two sections. So before we call for a start, we have what we call the initialization blocks. These blocks will provide information to the robot, but will not make anything move yet. Anything that is designed to make the robot do something will be in the part under that. So after the wait for start. So let's add some code. And by the way, you can get rid of these blocks if you want, because they're just there to provide you with this information. So to make our robot move, we do need to get those wheels going. So just to quickly show you, I'm going to go under actuators. Actuators in robotics are parts that will do something. They're like, if you listen to the word actuators, it's almost like the word action. And you will find what we call our DC motors here. So I'm going to bring one of the blocks called set motor left power to 1. And we're going to bring it in the sequence here. See, set motor left power to 1. Just so you know as well, 1 is a big number when we're doing robotics. 1 means 100%. 0 means 0%. So we're going to be using decimals a lot. If you want to do 50%, you will put 0.5. 60% would be 0.6. So 1 is like the fastest. It's 100%. So that makes this motor go the fastest it can go. So let's give this a try. So I'm going to reset and run the code. And I want you to look at what we get here. We kind of have a crazy robot that just spin on itself. And as you can see, the right wheel was kind of locked and the left wheel was the one moving. So the problem here is if we want to go in a straight line, we need to put power to both of the wheels, not just the left wheel. And here, if I use this one, I can select right or I can select left, but I cannot select both at the same time. So we're going to get rid of this block now that we've tried it, and I'm going to show you where you need to go. Still under actuators, DC motors, I want you to go to do. And now you can see this magic block will let me set the power for the left and the right motor. So we can expect our robot probably to go in a straight line. But I think you'll be surprised. Let's have a look. So see, my robot is now spinning. It is spinning differently than it was in the previous attempt. Because in our previous attempt, it was spinning, but one wheel was locked. Now it seems like the right wheel is spinning forward, but the left wheel is spinning backward. And that's weird because I put both of my numbers to 100%. So we would expect the two wheels to go in the same direction. But the thing is, if you remember what I showed you earlier, and let me go back just to make sure that you remember that. If we go back to this, you will see that when you build a robot, the way the motors are installed, they are kind of flipped. One is in reverse. So the motor on the right is installed so that when it goes clockwise, it will go forward. But on the left, because it's flipped, it's actually going in the reverse direction. That's why we get this one wheel going forward, one wheel going backward. So one thing that we could do is to always remember to put our left motor as a negative, like this. And that would make it work. Let me quickly show you. See, it goes in a straight line. Yeah, but I would always have to remember that my motor left has to be negative. So that seems a bit tedious. So what we're gonna do is we're actually gonna change the code in the initialization section. Basically, I'm gonna tell my code, hey, just so you remember, the motor on the left side is reverse. So to do this, we're gonna go under the DC motor again, and you're gonna grab that second block. Set motor left direction to reverse, like this. Now I can get rid of this blue thing, because now I know this is for initialization. So just before my wait for start, I have my initialization block, and then after that, I have my regular blocks. You could also bring one that would say something like, let me show you. You could say something like this, motor right, and then say this one is forward. But you don't need to say about the motor on the right because by default, the motors are set to forward. So you don't need to say that. The code already knows. So that's not necessary. So now if I put both of my motor at 100% and we start the code and let me zoom out, you see we're gonna reach the path. And it says, congratulations, you got a badge, amazing, you're awesome. Now it's gonna say, do you wanna continue or do you wanna keep working? And I'm gonna ask you to click keep working. And there's a reason I want you to do this. Is because when we did it, it's not perfect. Because the robot does touch the path, but it keeps going. See, it hits the wall. If there was no wall, that robot would actually fall off the surface. That's not good. So let's try to make this better. What we want is to make the robot move and stop when it gets to the pad. So we need to add some sort of a stop motor so that the robot will start and then stop. So to do that, let's go back to our code. And I'm going to bring a stop. So stop is basically putting both motors at 0. So I'm going to go under dual and see there's a block here. So this is going to put it at 100%. And after, take it 0. I'm going to reset, run. And as you can see, nothing is happening. And the reason nothing is happening is because it starts and it stops immediately. So it never has a chance to actually move. So what we need to do is to put some sort of a pause in between the two to give it a chance to move. And in FTC Sim, the pause will be available under the linear up mode. You can find it right here. And the pause is not expressed in seconds, it's actually expressed in milliseconds. So 1,000 milliseconds is basically a pause of 1 second. So let's give this a try. As you can see, I almost reached that pad. So now all you need to do is to do a bit of tweaking of your code to make sure you reach the pad. So I know I need a little bit more. So let's try with 1200. A little bit better, but not perfect. So I'm going to say keep working. Let's try again. So maybe 1300. Oh, pretty close. Almost there. See, that's almost there, but just a little bit more. So I think I'm going to go 1350. Okay, so let's give this a try. And I think we've got perfection here. Yeah, this looks pretty good. Look at this. My robot is well centered on the surface. So we have a solution here. Now, what I want you to do is to keep working. Because even though we've successfully did the challenge, I want you to try to change the speed here and see how it affects your millisecond. So right now I'm at 100%. Let's try it at 50%, 0.5, and see how this will affect the outcome. So see at 0.5, obviously it doesn't reach the pad, so I will need to increase the time. So I'm going half the speed. So should I go to double the distance? Let's try 2 seconds, which is not enough. Let's try 2500. Oops. Let's see what we get. Pretty close. Like it does accept it, but I think I would like to have a bit more perfection here. So let me go 2600. Let's see what we get. Hey, pretty good. Let's add a little bit more because I could move forward a little bit. 2650. I think I can go even to 27. Here we go. Much better. Look at that. This is pretty good. So now what I'm going to do is I'm going to pause the workshop a little bit, give you time to test it out. And then I would like you to try different speed. Like we did 50%, we did 100%, try 40%, 20%, 80%. And I'd like you to send to Martin your speed and the time that goes together. Like in this case, I would say I went to 50% and I used 2,700 milliseconds. So I'm going to disappear for 30 seconds, a minute, give you time to send your answers to Martin, and then I'll be right back. Okay, I am back. I think we're ready for the next mission. So let's run the code one last time so we can switch to the second puzzle. Now it's loading the second puzzle. Loading. Here we go, it's coming. Okay, and now we do have our friend with her dog Dozer. So let's make them disappear just for now. And let's have a look at the new challenge. So I'd like you to have a look at what you think is different from the first challenge. And to help you, I'm going to zoom in on the robots. Let's zoom in on the robot. You should see something different. So take some time to discuss in your class what are the differences between what we had before and this new one. And you can also send Martin your answer. Martin's going to be looking at them. So what do you notice is different? I'm going to put it full screen, let you think about it, and then we're going to start solving it.
We have some people that said the distance. Some people said that the robot looks different a bit.
Okay, so you probably told Martin that it doesn't seem to be as wide. It's quite narrow when you look at the path that the robot has to move through. And the second difference that you probably notice is the robot is backward. So if we were to make it go forward, it would actually hit that wall instead of going towards the target. So there's a bit of work to do here. So different ways to solve this puzzle. One of the ways to solve the puzzle is to actually go backward. So let's try to do it by going backwards. So I'm going to load the code. Once again, for this puzzle, we don't need the repeat, so we can put it in the trash. We don't need this because we know that this is where we're going to put our block. For our initialization block, we do need to bring the motor left in reverse. Remember, we do this because the motor on the left is flipped compared to the one on the right. And now we're going to start putting our dual motor, which is this one. We also need a stop. So we're going to have a start and a stop. I won't go full speed, especially how narrow it is. I don't want to go too crazy. And then I do need in between some sort of a weight block, which we call a sleep, like this. So let's give this a try. And see now I'm going in the wrong direction. So to go in reverse, you need to use negative numbers. So instead of 0.5, let's use negative 0.5. Let's see what we get with that. Okay, we're doing quite well. As you can see, when I start it, it goes backward. But it doesn't go backward enough. So what I need to do is probably double the time here. Let's go with 2,000. Okay, better. Let's try 2,400. It does consider that I've successfully done the challenge, but to me, that's not perfect. So let's keep working. I want to be completely on the pad. So 2,600 maybe. Oh, I could go a little bit more. Let's keep working. 2,700. A little bit more.
Probably has to be fully on the pad.
800. Yeah, I think so. Okay, let's try this. Oh, I think that's a pretty good solution. So let's have a look. Keep working so we can look. Yeah, it looks pretty good. Yeah, I could go a little bit more, like 2,850, but it's pretty good. Let's try 2,850. Yeah, sounds good. That sounds good. Okay. So I told you that's one way to do it, but there's more than one way to do it. So the other way to do it would be to turn around and then go in a straight line instead of going backward. So let's try to do it the other way. So to turn around, you're going to need to put one wheel forward, one wheel backward. Remember when we did that in the first puzzle? So we had one wheel forward, one wheel backward. So let's give this a try. So I'm going to go negative 0.5 and 0.5 like this. So that should make it turn around. But see, it turns too much. So now I want to not turn as much. I basically want to do a 180 degrees. That's a bit too much. So let's try 1,800. Almost. 1,900. Pretty good, I think, I would say. Looks like it. Yeah, looks like I'm doing very well. So now that I've turned around, the next step would need to go forward. So we need to add more code here because those 3 blocks are designed to turn around. So now I'm going to add 3 more blocks that will be designed to go in a straight line. So move forward here, then the sleep mode, and then I'm going to go with a 0. I don't like to go too fast, so I'm going to go 0.5, which would be to go forward. So let's try this. So turn around in a straight line. Pretty good. Now I just need to have enough to reach the path. So 2,400. Let's see. Pretty good. I need to go a little bit more. Let's say 2,700. Wow, pretty good. I think I've turned a bit too much. See, I'm a little bit too much on the right, but that would be good. Like I would accept that, but I like perfection. So let's go 1850 here. And that's not enough. So I'm a little bit too much to the left now. So let's go 1875. The quest to perfection here. Oh, much better. Here we go. So now we've done it. Now we're going to keep working because I want to show you, you one more thing with this puzzle. So now that we've done it, as you can see, my code is getting quite long. So there's 2 parts to this code. There's this part, which is to go in a straight line, and this part, which is to turn around. So let me show you how you can split the code so it makes it easier when you want to make a change to see where the mistake or the things is. So one thing that we're going to do is we're going to create what we call functions. And to create functions, you're going to come here, that last section here, and you'll find robot function. And the robot function right now say, do something. So I'm going to bring them here, and I'm going to actually bring 2 of them. And where it says do something, I can actually rename them with something that makes sense, like a real word. So in this case, I'm going to say, I want you to say turn around, because that's what it's going to do. And I'm going to take the code for turn around, and I'm going to bring it here. So see, now I have this code, which is designed to turn around. Now, this one would be to go to straight line. I'm going to call it straight line, and I'm going to take this code and bring it here. So now what we have is those 2 functions, turn around and straight line. If you try your code at this point, let's give this a try, you'll see that nothing happens, nothing moves. And the main reason why nothing moves is if you look at the main code, there's barely no code left. And these functions will not be used unless you call them. So let me show you how you can call a function. So to call a function, you're going to go into robot function, and you're going to find these blocks here. So basically what we've done is we have created our own coding block. We made them up. So now you can use them. So let's say I want to turn around, and then I want to go in a straight line. So your main code is a lot cleaner. Like it's a lot more obvious what you're doing with your main code. And if you need to make a change, like let's say your problem is in the turnaround, you know exactly where to go to change it. If your problem is in the straight line, you know where to go. So I encourage you to always split your code and organize your code in sections that make sense using functions. So now if I try it, I basically get the same result as before, but my code is a lot easier to read. The cool thing is you can also reuse code. So let's say you wanted, and this is not the case, but let's say you want to go in a straight line, then you want to turn around, then you want to go in a straight line. You could do that. So now your code can do that straight line, turn around, and then straight line. That's not what I want. But as you can see, you can reuse your code more than once. So that gets very useful. Like I have a lot of students who will create a function which is to turn 90 degrees. So whenever they need to turn, let's say turn right 90 degrees and turn left 90 degrees. We often have to do that. So whenever they need that, you just call the function and they now have code to turn 90 degrees. That simple. Okay, so I think we can run the code one last time for this one and say this one is done so we can move to puzzle number 3. And I'm going to say, yes, got it. So I'm going to say continue. And that's going to take us to our last puzzle. Let it load.
Good job so far. I think our participants are enjoying it.
Okay, so let's hide this. And now let's have a look at our puzzles. So in this case, as you can see, the puzzle, we kind of need to move, then turn and move, turn and get to the target here. So I'm going to start with a little straight line, not too long. So remember that we need to remove this. I can remove this. I can move this. All I need to know is before the wait for start, I put my initialization block, and after I put my regular block. So let's put my first and only initialization block, which is to set the motor left to reverse. And then let's start moving in a straight line. So I'm going to use this one. Now I'm going to put a little sleep. And I'm going to put a little power off. So let's see 1 second where it takes me. Oh, that's too much. That's way too fast, especially for this size of a puzzle. I don't want to go too fast. Okay, that's pretty good. I think I can start to turn now. So now I went into a straight line. I'm going to turn. So I'm going to set my motors here to, let's say, 0.3 and minus 0.3. And then I'm going to call the simulator for sleep and then stop. And let's see what we get with that. It's okay to solve the problem little step by little step. Pretty good? Okay, so now I think I'm ready to move again in a straight line. So straight line. As you can see, my code becomes super long though. So I will want at one point to probably organize it and split it the same way I showed you in the last lesson. Okay, let's see what we get with that. Perfect. I think we're doing pretty well. Now I think I need to turn a little bit more. For maybe a second and then stop. Let's see what we get here. Oh, that's a bit too much. So maybe something like this. That's a bit too much. We're getting pretty close though. See? And now we want to move a little bit forward. So I want you, maybe you want to pause the workshop or just mute me and complete it yourself. So that would be fun if you did it yourself. But you see where I'm going. Just putting a bit of movements one after another to get to the results that I want. Okay. And then basically I'm ready to turn and get to that target. So I'm going to turn it even more. Getting pretty close there, right? Go. You don't have to do the exact same thing as I do. You can create your own way to solve it. So that's a little bit too much here. See, I'm getting pretty close to that target now. And what I'm trying to do is to not touch the wall. I do touch the wall a little bit here. So I think I'm gonna, my first one, I'm gonna go a little bit more here. So I'm not touching that wall. Yeah, that's much better. Okay, so now I need to move forward. See, that code is becoming long. I definitely need to split this to make it a little bit more obvious what I'm doing. Good. Oh, and it looks like I've completed, but I actually need, what I would do to get a perfect score here, I would turn a little bit more and move forward one last time until I'm completely on the target. So hopefully that gives you a good idea on how you can code your different movement. Now, I would like to show you, if you want to go further, what you can do, because so far we work only on movement. So let me show you some of the other lessons that are part of FTC Sim. So if you want to explore those lessons by yourself, you can do that. And teachers, we also have lessons on learn.logicsacademy.com, learn.logicsacademy.com. These lessons are free, and they have all of the answer keys for you as well. So if I come back to FTC Sim, to the courses, leave here. So far, we've done movement. And if we keep looking at movement, see, we've completed the first three. Here, you're going to have an L shape. Then you're going to be working a square, a turn text, a helix, and then around the world. The last one is always a little bit more complicated. It's more of a challenge. Now, let's have a look at what we have in the other ones as well. So, if I go under FTC sensors, you're going to see that there are two sensors installed on your robot. There's something called a color sensor, and there's something called the distance sensor. So let's start with the color sensor. So I'm going to load color sense here. It's coming. Yeah. So I want to bring to your attention what we have here. Here we have some randomness, which means there's two paths, and you will not always go to the same path. So in this game, whenever you start the game, you see this time the path is red and the red gate open. So if it's red, you're going to need to turn left and go on the left path. When I say left, let's imagine we're the robot here. So see, the robot would be going, looking at the pad, it's red and turn, but every time you load this game, it's going to be a different color. Like right now it's red, blue. So when it's blue, it needs to go to the right. So to do that kind of coding, what you're going to need is to use the color sensor. And the color sensor is available right here under sensor. You're going to find color sensor. And with the color sensor, let me zoom in a little bit. You can get how much red, green, or blue is visible. So you're going to get that color, okay? And the reason it's red, green, blue is those are the main color of a screen. Red, green, blue, that's why we call this an RGB screen. So finding the red and the blue on the pad should be easy with what you have here. And you will also need some logic. So the logic is an if statement. It's under logic here. And when you have an if, you can actually add an elif like this, which will give you two options. So you could say if the color sensor is detecting red, then do this, which would be to turn left and then go in the pad. Elif, so if it's not red, but it's blue, so you would put if it's blue here. So you attach the condition, and inside here you would put the code, which would be to turn to the right and then go on the pad. So to do these, you will need to reach the pad first. So if you were to check the color right now, you would not get a reading. So you'll need to make your robot move all the way to the pad, then check the color, then make a decision using an if statement. So I won't do it all for you. I want you to explore that, but this is what you can do with the color sensor. Now let's have a look at the other sensor, which is the distance sensor. So the distance sensor is available here, and you can get the distance of the obstacle in front of an object in centimeters. So let's go and have a look at a puzzle that is using the distance sensor. So I'm going to go under FTC sensors, and the puzzle number 7 is using the distance sensor. Here we go. So in this case, every time I load the puzzle, that wall is going to move a different way. Let me show you. Sometimes it's going to run this way. So that means the obstacle in front of the robot is pretty close. Whereas if it turns the other way, like this, then the distance is further. So in this case, we're going to use the sensor, the distance sensor, which would be under sensor here. So let me zoom in a little bit. And you can measure the distance in centimeter. So that distance, you can then use an if statement. If the distance is greater than, let's say, 50 centimeters, then do that. If it's less than 50 centimeters, then do something else. Same idea that we did with the color, but now we're doing it with distance. And specifically in this puzzle, what you're supposed to be doing is, if the distance is super long, then you're going to go further and then turn left to go to the furthest pad. If the distance is shorter, then you're going to go a shorter distance and you're going to go on the first pad. Now keep in mind that your bonuses here, they try to make it hard. So this one, the lightning bolt, is fairly easy, but the duck is quite of a challenge because you need to go and get it and then come back. So this is sensor. The last thing I want to show you, if you want to go further, is to use the grabby. And the grabby is designed to grab an object. And you will find this in the lesson here. See the FTC grabby. And the grabby is basically something to grab an object. So let's go and have a look. It was not available in the robot for the first few lessons, but for these lessons, you will find the grabby on it. So loading the lessons, coming. Here we go. So as you can see, there's this here on the front. And the idea is it can go up and down. The idea is that you will bring it up, move forward, and then grab the Lego piece. So then you can bring that Lego piece whenever you need. In this case, you need to bring that Lego piece on that pressure pad to trigger the opening of the wall. So where in the code will you find a way to make the grabby move? It's under your actuator. See, we only had DC motor, now we have also servo. In the servo, you can set the grabber to a specific position, and that's going to make the grabber move. So teacher, if you need extra help in supporting your students for these lessons, make sure you go to learn.logicsacademy.com. And this is what I had to present to you. Hopefully you've learned a lot. It was a pleasure presenting to you, and Martin will provide you with the end of the workshop survey and with some further information. Thank you so much, and have a great day.
Thank you so much, Dominic. That was great. Thank you for this presentation. What a lesson. Thanks again, Dominic. Now, if you want to connect with us or want more information, this is how you can reach us. Your feedback is super important. So please fill out the feedback form that will be coming for you in your email. This is a little homework for your teachers. And I would like to thank you so much for joining us today on behalf of Logics Academy and wish you a nice day.